Okay, here we are at 3.4, day number 2, derivatives with sparse data. So if we're just given a little bit of data in this table, of course, -2 to 2 for x, we're given f's values, so the outputs of f, the derivatives for each of those values, g's values, as well as the derivative of g's values, and we got a question mark there for g prime of 2. This isn't a lot of information. We wouldn't be able to tell, for example, what the derivative of f of x would be at x equals 3. We could guess, but we couldn't be that accurate. So let's let h of x equal e to the x times f of x. What is h prime of 0? I'm going to do a little work off camera and then we can analyze it. Okay, so the derivative of h would be the derivative of the first, e to the x times f of x, which is the second, plus the derivative, plus the first times the derivative of the second. So if I want h prime of 0, I would have e to the 0 times f of 0 plus e to the 0 times f prime of 0. E to the 0, of course, is 1, f of 0 is 5, and f prime of 0 is 9. So h prime of 0 would have to be 14. Okay, in the next example, we're given that j of x is equal to -4 f of x times g of x. So off camera, I'm going to go ahead, and you can try this on your own as well. I'm going to calculate j prime of x. Okay, so I used a little bit different method. I pulled out the -4 and then used the product rule method and did f times g prime plus f prime times g. So if I want j prime at 1, the derivative at 1, I just plug in a 1 everywhere. And I'll simplify here in a moment. So j prime of 1 equals -4 times the quantity f of 1 is 3, g prime of 1 is 6, f prime of 1 is -3, and g of 1 is 2. So j prime of 1 will equal -4 times, looks like 18 minus 6, which is 12. So j prime of 1 equals -48. Okay, same numbers have been translated for us. Let's let k of x equal x times f of x over g of x. What is k prime of -2? Okay, so off camera, I'm going to find k prime of x. Be right back. Okay, a bit of a mess here, but low times the derivative of the high. Of course, the derivative of the high, I'd have to do the product rule, so derivative of x times f of x plus x times the derivative of f of x minus, so this is low d high minus high d low over low squared. So let me jump into k prime, prime of -2. Ooh, this is a mess. I'm going to plug in a -2 everywhere and I'm going to evaluate. I'll come back with an answer in just a smidge. Okay, I've done some evaluating here. You can pause the video if you'd like to. Looks like I'd get k prime of -2 is equal to -5 times 1 minus, that'd be a -48 over 25. Looks like to me I'll get a 43 over 25. So that would be the instantaneous rate of change of k of x at x equals -2. Alright, let's take a look at the next one. Ooh, this one's kind of funky. Okay, so I'm going to consider this a function. I'm going to consider this a function. So I'll have a product rule embedded in that second function. I'll come back with I'll call this L of x. I'll come back with the derivative in just a moment. Okay, there's our derivative. Derivative of the first times the second plus the first times the derivative of the second. So if we're told if L prime of 2 equals negative 48, so negative 48 would equal 3 times 2 squared times f of 2 times g of 2 plus 2 cubed times f prime of 2 g of 2 plus f of 2 g prime of 2. It tells us to find g prime of 2, so we're looking for this. So we can assign values to the rest of this stuff. I'll come back with a simplified version of this. Okay, so I did some work on the side here. And I just gave values to each of these, okay, appropriately given in the table of our known values. And all I'm trying to do is simplify down to get g prime of 2. So I'm going to take 432 and I'm going to divide by 8. I think that comes out to be 54. Okay, so I get 54. 54 equals 24 minus 5 times g prime of 2. Okay, I'm going to subtract 24, so I get 30. So I get 30 equals negative 5 times g prime of 2. So it looks to me like g prime of 2 is equal to a negative 6. Okay, so here's another example where we're given a little bit of information. The table above gives values of differentiable functions f and g and their derivatives at x equals 1. Find h prime of 1. Well, let's first find h prime of x. Derivative of the first would be 2f prime of x. The second would stay 1 plus g of x. The first is 2f of x plus 3, and the derivative of the second would just be g prime of x. So if I want h prime of 1, I'm going to plug 1's in here, and it looks like I'll get 2 times f prime of 1, which is negative 2, times the quantity 1 plus g of 1. G of 1 is negative 3, plus 2 times f of 1, so 2 times 3, plus 3 times g prime of 1, g prime of 1 is 4. So that would be negative 4, right? Negative 4 times negative 2, which is 8, plus this would be 9 times 4. That'd be 6. Yep, 6 plus 3 is 9 times 4 is 36. So I'm thinking I get 44 for h prime of 1. Alright, the next problem is a breeze. It looks complicated, but it's not. Right, what happens to this function as x goes to 0? This is one where you're supposed to memorize. It goes to 1. So in order for this to be continuous, right, my right and left limit exist right here, right? But we want those to equal f of 0. Well, we want f of 0 to equal 1. Therefore, we want k to equal 1. The equation of the tangent line to the curve that at x equals negative 2 is y equals x plus 4. What is the value of k? Alright, so I'm going to find the derivative of y. I'm going to find y prime. I'll be back with that answer in a moment. Alright, so I used the quotient rule here to find the derivative of this function, and it looks like our derivative comes out to be this. Now what we want is when x equals negative 2, right, when x equals negative 2, we want our slope to be what? Right, we want our slope to be 1. So we want y prime to equal 1. So if y prime equals 1, we get k minus 2 squared. We could get that to equal 1 if we cross multiply. I'm going to erase a little bit here. If I cross multiply, I get k minus 2 squared equal to k squared minus 8. Well, this is k squared minus 4k plus 4 equals k squared minus 8. Looks like to me the k squareds will cancel. So negative 4k equals negative 12. Looks like k would have to equal 3. Just so we're understanding here, I wanted my slope, this was my slope equation, my derivative, to equal 1 because the equation of the tangent line had a slope of 1. Let's move on to the next question. Alright, the twice differentiable function f is defined for all real numbers and satisfies the following conditions. F of 0 equals 2, f prime of 0 equals negative 4, and f double prime of 0 equals 3. The function g is given by this function, e to the ax plus f of x for all real numbers where a is a constant. Find g prime of 0 and g double prime of 0 in terms of a. Show your work. Alright, so what I'm going to do is I'm just going to take and find g prime of x, which would be a e to the ax plus f prime of x. So if I want g prime of 0, that would be a e to the a times 0 plus f prime of 0. So g prime of 0 in terms of a, this will come out to be 1, so that'll be a plus f prime of 0 is negative 4. So really I have a minus 4. There's g prime of 0 in terms of a. Now let's find g double prime of x first. So I'm going to take the derivative of that expression. That would be a squared e to the ax plus f double prime of x. So g double prime of 0 would be a squared e to the a times 0 plus f double prime of 0, which would be a squared times 1 plus f double prime of 0, which is 3. There would be g prime of 0 in terms of a. That'd be it for 3.4 day number 2 sparse data. Have a great day.